Dear friends, welcome to my video. Kindly click on the CC button for subtitles. Understanding the world around us has always been one of humankind's most fundamental pursuits. From our earliest ancestors staring up at the night sky to modern scientists probing the deepest mysteries of the universe, we are driven by curiosity. Quantum mechanics is a significant step in this ongoing journey of discovery. It might seem complex, but with some patience, beginners can grasp its rudimentary concepts. Quantum mechanics is the branch of physics that deals with the smallest particles in the universe, such as atoms, electrons, and photons. It was born in the early 20th century when scientists realized classical physics couldn't explain the behavior of these tiny particles. One of the most important principles in quantum mechanics is the concept of wave-particle duality. According to classical physics, light was seen as a wave, while matter was made up of particles. However, experiments like the double-slit experiment and photoelectric effect led to the groundbreaking discovery that particles can behave like waves and waves like particles. For instance, electrons, which are particles, can create interference patterns like light waves, while light can interact with matter as if it were made of particles, called photons. Quantum mechanics also introduces the concept of superposition. It proposes that a quantum system can exist in multiple states or places simultaneously until it's measured or observed. This concept is famously demonstrated by Schrödinger's cat thought experiment, where a cat in a box is both alive and dead until someone opens the box to check. Another fascinating aspect of quantum mechanics is the notion of entanglement. If two particles become entangled, the state of one instantaneously affects the other, no matter how far apart they are. It has been experimentally proven, challenging our fundamental understanding of space and time. Quantum mechanics also has a probabilistic nature. We can't predict exact outcomes but can only calculate the probabilities of various outcomes. This is embodied in the Heisenberg's uncertainty principle, which states that it's impossible to simultaneously know the exact position and momentum of a particle. The more precisely one of these is known, the less precisely the other can be known. These principles might seem counterintuitive because they don't align with our everyday experiences. However, they are precisely what make quantum mechanics so intriguing and why it has successfully explained and predicted various phenomena at the microscopic level. Quantum mechanics has had profound impacts on our technology too. Semiconductors, lasers, MRI scanners, and even computers owe their existence to our understanding of quantum phenomena. Quantum computing, a field still in its infancy as of my knowledge cut off in 2021, exploits superposition and entanglement to perform calculations at a scale and speed far beyond classical computers. Despite its strangeness, quantum mechanics has stood the test of time and experiment. It remains one of the most successful theories in physics. But, as Feynman famously said, if you think you understand quantum mechanics, you don't understand quantum mechanics. This merely highlights the depth of quantum mechanics and the mystery that still surrounds it. Quantum mechanics pushes us to challenge our assumptions and expand our understanding. It might seem daunting, but don't be discouraged. Every great scientist was once a beginner. So, if you're curious about the world, be patient, keep asking questions, and never stop exploring. Quantum mechanics is a difficult subject, but the journey of learning it can be immensely rewarding. It offers us a new lens to look at the universe, and in doing so, shows us that reality is much stranger and beautiful than we could ever imagine. Thank you for watching my video. Kindly subscribe to my YouTube channel and give a thumbs up. Thanks for your support.